Hello students, I'm making this video to explain the solution for the problems which were given in the first exam of this semester on 26 March 2024. I'll be solving the problems from the different question papers which were given in different times and sections. I'll start with this one. So the question is very easy. You were given with the data for each month of the year and you were asked to calculate the AWT. AWT means that it's the average weekday traffic. So you have the total vehicle count and then you have the number of weekdays in each month. So you were simply asked to divide it. Okay, so for example, the traffic is 26,479 in January. The number of weekdays in January are these, and this is how you will get it. Okay, and this will be done for all the months. So just simply divide column 2 with column 3 and that's it. Okay, these are the answers. Okay, as we do normally with the flow or volume, I rounded off to the nearest number, nearest integer. Okay, in this question we were asked to fill up these missing values. Okay, so I'll start with this one. So if you have a value before and a value after and the middle value is missing, then you simply take an average. So this one will be 383 plus 311. Okay, the previous and the next number divide by 2. Okay, so this will give you the solution. Okay, now you can see here that we are so these are the values, okay, like with the missing values. Okay, so there was one mistake. I may have corrected it in the class as well. This should be this should not be 413, it should be 415, and the rest of the things same. Okay, like these are 15 minutes interval. Okay, okay, so all of them are 15 minutes intervals. There was no gap, so this was a mistake which I corrected in the class as well. Now you can see still there's one value missing here and one value missing here. So how do we fill in these values? So I explained in the class as well. You take the immediate value, which is 383, minus the next value, which is 347, plus the immediate value again. Okay, so this will give it the solution, and in this case the immediate value is 305 minus the next value is 312 plus 305. Okay, so these are the values in the end but they are calculated in this way. Okay, now the last question was about calculating the Z value. So Z value is calculated by taking the upper limit for every interval. Now for the first case, the first interval, the upper limit is infinity, so it will remain infinity, it will not change, so you don't have to do anything for the Z in the first case. In the second case, the upper limit is 48, so 48 minus the mean. Okay, this value, it was given 40.86 divided by the standard deviation, which is this value. So this will be done for all the cases. So in each case you will just change this number. Okay, okay, so these are the values in the end. Okay, and usually we round it off to the 2 decimal places because in the Z table we have up to 2 decimal places, but if somebody didn't round off, there's no problem with that. Okay, so this problem, this is from the other section and it's very similar to the one which I gave in the previous section. So you have to now calculate ADT instead of AWT. You have to calculate ADT. So instead of weekdays, you will use the full number of days. So we have ADT here. So it is again same, 26479 divided by 31, the total traffic upon number of days. So these are the values in the end. Just like I mentioned, just divide column 2 with column 3. That's it. And again round it off to the nearest integer. Okay, then we have the next one. This question we are required to calculate the values for 15 minutes interval. Okay, so they are essentially here for 13 minutes. Okay, so first of all I will change it to 15 in writing. Okay, so these are the intervals which are given, and these are the intervals which I want to make them. Okay, so what will I do with this value? I'll multiply by 15 because I want 15 minutes, and divide by 13 because given for 13 minutes. So this will happen with all the values. Okay, so these are the values in the end, the 15 minutes values. But what we did, we took the value from here, multiply by 15 because we want it for 15 minutes, divide by 13 because they are given for 13 minutes. This happened with all the values, no exception. Then we have question number 3, in which you are supposed to calculate the standard deviation. So for standard deviation we need the n into s square. I'll add a column here, n s square. Okay, so what is n? N is this. And what is s? The s is the middle of these two values, upper and lower. Okay, so then I should make another column. Okay, so I call it s, and I need the middle. So 30 and 32, middle is 31. Okay, then they will increase by 2 miles per hour. Okay, so then you simply take the square of any value in this column, multiply by the value in this column. Okay, so this is what I did. In the end, in the equation, I will need the sum as well, sum of these values. So I'll do the sum now. So sum is 148206. Okay, now I'm going to use this equation. We take it from here, put it here for reference. I'm trying to calculate s here, smallest. Okay, so I'll take the square root, some bigger bracket here. Okay, so sum 148206 minus, what is n? N is the summation of this column. Okay, so summation of this column is 86. So 86 multiplied by the square of the mean. This is the mean which is given, 41.19. Taking its square. Okay, so numerator is done. Then the denominator, you have n minus 1, so n is 86, n minus 1 is 85. So, and then you do the square root of everything. Okay, the answer to this one is 5.19 miles per hour. You can have a little bit of difference because of rounding off or something. It's no problem. It's 5 point something. Okay, this is the question which the question paper which I submitted in the same section. I give in the same section, but to different students. So you have to calculate the sample size. Okay, the equation for sample size is this one. Okay, so I'll pick it from here, put it here for reference. Okay, so I need n, small n. Okay, so it's 3.84 multiplied by the s, the standard deviation. Standard deviation is 4. So 4 square divided by the tolerance is 2, so 2 square. It's very simple. Okay, so it comes out to be 15.4, and now round it up to 16. We cannot round down. Okay, next one, we have a speed density equation. The speed density equation we have, and then we are required to find out, first of all, free flow speed and jam density, and then we are required to find out the relationship between flow and density, and then find out critical density and capacity using the equation which we already have. Okay, so for free flow speed, density is 0. So in this equation, you put density as 0. So your free flow speed equals to S at D equals to 0, and that is 71 miles per hour. Okay, then we have jam density. Jam density means D at S equals to 0. Okay, so now you replace S with 0 here. Okay, so this will be 121 vehicles per mile per day. Okay, normally these are the units, but if somebody just wrote vehicle per mile, that's fine. Okay, then we have to draw the relationship between flow and density. So I have to replace S from here somehow. Okay, so for replacing S, I will use this equation. So from this equation, S equals to V upon D. Okay, so I will use this one now. I'll go back to this equation. So V upon D equals to this whole thing. So that means D equals to, sorry, not D, V equals to 71D minus 71 upon 121. I'll put it in bracket. D square. Okay, and to further simplify it, 71 upon 121 equals to 0.59, so D square. Okay, so now to find out the critical density, first of all I will take the derivative of this equation. So derivative of this equation is 71 minus 2 into 0.59 D. Okay, and this should be equal to 0 because critical density means when the flow is maximum. Flow is maximum means the slope is 0. Okay, so this will give me critical density . .5 vehicles per mile per lane. Now for capacity, you can put critical density into this equation, so it will give you critical speed. Then you put speed and density in this equation. This is also fine, but since I already have the equation between flow and density, I would use that one. Okay, so I'll put D here as 60.5. So the flow will become my capacity. Okay, so this is the final value, which is capacity. Okay, so I just put the critical density into the flow equation. Okay, so I'm calling, then when you put critical density in the flow equation, then I'll call it capacity. Okay, now in this example, we are required to calculate the peak hour volume, and peak hour factor for each direction. Okay, so for each direction, I have to make a separate column. I will call it hourly volume. So hourly volume obviously will start from here. The first 4 values will make an hour, and then the next 4 values, and then the next 4 values. Okay, so you have to combine 4 values, the intervals or the sets of 4 values, which will give you the hourly volume. Okay, so these are the hourly volume. Just to explain what I did, I combined the sets of 4 values. So this value starts from 4 p.m. and ends at 5 p.m. The second value starts at 4:15 p.m. and ends at 5:15 p.m. Okay, so the sets of 4 values, those are the ones which are combined, and same thing for the other direction as well. Now if I'm doing it for the eastbound, then okay, so you can see here the maximum I have is this one. Okay, so my peak hour is from 4 to 5. Peak hour volume is 1443. Peak hour factor will be this volume divided by 4 times the maximum flow in the same range, the range from which this value came. So the maximum is 383. Okay, so this comes out to be 0.94. Okay, again, if there's a small difference in the decimals, there's no problem with that. And you have to repeat the same thing for the westbound as well. So you can see here the peak hour. Where is the peak hour? 1183. I have 1186, and then I have 1202. So this is the peak hour now. Okay, 1202. So this is now from 4:45 to 5:45. These 4 intervals were combined, right? So 4:45 to 5:45. Okay, the value is 1202. So 1202. What is the maximum flow now? From 4:45 to 5:45. So these 4 values. So the maximum is 332. Let me check the value. So this one is 0.90. Okay, so this is how it should be solved. I hope everybody got it right, and for those who didn't, try harder next time. Okay, see you.